Cloud is all about choice. Take full advantage of multi-cloud with Couchbase, a geo-distributed, cloud-native data platform built to power your business-critical applications. Avoid cloud lock-in and open up a world of possibility. Start a revolution with Couchbase. Learn more at couchbase.com/cloud.
Welcome to the InfoQ Podcast. My name is Wesley Reisz, and I'm your host. The InfoQ Podcast is brought to you by InfoQ.com. InfoQ and the software conferences QCon, which I chair, bring to you innovator, early adopter, and early majority software feature articles and news, conference sessions, and podcasts for senior software engineers and architects. On this week's podcast, I speak to Aditi or Shubha Nabar. Shubha Nabar is a senior director of data science for Salesforce Einstein. Prior to working at Salesforce, she was a data scientist at LinkedIn and at Microsoft. On this week's podcast, we discuss Salesforce Einstein and the problem space they're trying to solve. We talk in detail about the differences between the consumer and enterprise space for machine learning. And then we go into a bit of a library and talk about Optimus Prime that they're using at Salesforce. Finally, we wrap up with the Patterns and Frontiers of AI track that she'll be hosting at this QCon San Francisco, November 13th through 15th. As always, thank you for joining us on the InfoQ Podcast. I hope you really enjoy it. Shubha, welcome to the InfoQ Podcast.
Hi, Wes.
So I can't go to any conference, a data science conference, a data engineering conference, a software conference in general, without hearing about Salesforce Einstein. What is Salesforce and what is Einstein?
So Salesforce is a platform that businesses use to manage all their customer relationships. And Einstein is basically bringing machine learning intelligence into this platform, making all of these business apps across Salesforce smarter.
So Salesforce Einstein is a layer within the Salesforce platform that lets you apply AI to some of the apps that people build for the platform?
Yes, and so this goes across sales, service, marketing, and more. And it's a platform, so you also have an active community of developers who build business apps on this platform and make them available on the App Exchange. And so you have literally hundreds of thousands of businesses and millions of people who are using Salesforce-powered business apps every day to manage all kinds of customer touchpoints. And so as an example, you could have hospitals using it to manage their patient records. You could have sales teams using it to manage their whole sales process from lead to cash. You have marketing teams using it to manage their marketing campaigns and so forth. And all of these businesses and all of these users want to get much more predictive value from all their data. They want their business apps to be smart in the same way that consumer apps are today, right? So they want the more Google Now kind of experience where Google Now is telling you what you need to do next and what you should be focusing on.
So what are some of the predictive use cases that you enable?
So there's some very common use cases that are common across businesses. So salespeople want to know how their deals to close, or you have marketing teams who want to do predictive segmentation of their audiences. Or you could have call centers that want smarter case routing, right? So these are some of the common use cases across businesses. But then there's also a really long tail of all kinds of other use cases. So for instance, we have universities that use Salesforce to manage their student life cycles, and they want to know how likely are students to accept their offers. Our very own finance department uses Salesforce to manage its transactions, and they want to be able to predict which customers are going to be late on their payments. So there's this very long tail of all sorts of predictive use cases that people have. And the problem is that for the majority of businesses, unless you're like Facebook or Google, unless you're in the top 1% of businesses, you don't generally have the data engineering or data science expertise you need to get that kind of predictive value from your data. So with Salesforce Einstein, we're trying to make it really easy to deliver this kind of predictive value from your data directly in the context of your business apps, and to make it so simple that you don't have to be a Google or a Facebook. You don't have to have armies of data engineers and data scientists to wrangle your data and analyze it and derive that value for you.
Help me understand though, when you talk about a pipeline for sales, or when you talk about a university managing the life cycle of a student, I mean, there's so many millions of possible data changes that are happening. How do you create a commodity pipeline that the University of Louisville and Stanford are going to be able to use interchangeably?
Well, so the nice thing at Salesforce that enables us to actually make a dent in this whole space, and it's a very complex space, is that we have very rich metadata about our customers' data. We know that this is your leads table and it joins with your accounts table in this way and so forth. So we know all the different objects in your database, how they relate to each other. And we also know for each object, we have very fine-grained information about this is a phone number and that's an email address and so forth.
Oh, I see.
And this kind of metadata allows us to actually automate a lot of things that a data scientist normally has to hand tune for every problem that he works on.
I see. So because you have deep insight of the data structure that's already there, you can make assumptions about things and be able to give them some form of predictive analytics. I get it.
So we can take a configuration basically, which is a specification of this is how this object relates to these other objects, and this is the structure of each of those objects. And then we can use that to now generate machine learning pipeline.
Okay, that sounds really cool, but how? How did you do that? What did you actually build that gives you the ability to do all of this?
Well, there's many different pieces to what we built. But one of the things we built was basically a framework that lets you specify the outline of a predictive problem. And then it automatically then goes in and does all the things that a data scientist would hand tune. So it automatically does the feature generation, the feature engineering, the feature selection, the model selection, the data balancing, and then the recalibration. So it does all of these things automatically for you using the metadata so that you don't have to have a data scientist dedicated to building every single model.
So when you say outline kind of the domain problem or the business problem, what does that mean? Is it a developer, an analyst? Who's actually doing this?
So what we've built so far, we have a platform that we've exposed to our internal developers, and our internal developers have used this platform to build packaged apps that we know a lot of our businesses are interested in. So things like lead scoring or opportunity insights and so forth. But the next thing that we're sort of moving towards over the next year or two is actually opening up the platform so that external developers, as well as less technical personas like external admins, can build their own custom models for their own custom needs.
So where are you in the process of exposing all this capability? What's the current roadmap?
So we've released APIs that make it possible for you to just upload a data set with labels, and then these APIs do things like sentiment analysis or image recognition. And they use techniques like deep learning to make this happen, to give you really high accuracy models. This next step is about making those APIs available, but very much in the context of your app. So you really have to do nothing. You just have to say, hey, I want to predict this field and this object, and that automatically happens for you.
I want to change gears just a little bit. If you put 5 data scientists in a room and ask them what the definition of AI is, you're probably going to get 6 different answers. What is Shubha's definition of AI?
AI is basically it's a science of building intelligent software, and it encompasses many different aspects of intelligence that we tend to think of as human. So it includes learning, reasoning, perception, language understanding, and so forth.
How do you distinguish that with machine learning?
Machine learning in particular, I guess, is teaching machines to do particular tasks by learning from past examples without explicitly programming them to do that, which is, again, sort of a very human kind of intelligence.
I think you were in a panel on AI by the Bay, and you said the thing that keeps you up at night is how to democratize AI technologies. What does that mean?
So again, it's making these technologies much more accessible. As I said previously, there are all these businesses and that are generating so much data, but a very small fraction of it actually gets analyzed and used. And unless you're a Google or a Facebook, unless you're in the top 1% of tech companies today, it's really hard for you to derive predictive value from your data because you need to have armies of data engineers and data scientists. And so all the work that we're doing at Salesforce Einstein is literally on democratizing these technologies to make it much more easy and for businesses to benefit from machine learning intelligence.
You gave an example in that same AI by the Bay panel that you were on where you were talking about AI and eliminating mundane tasks that some of your roommates were doing. Could you tell us that story?
Yeah, so some weekends I would accompany my roommate to the lab. She was a biologist. And she used to do her experiments on C. elegans, which is a kind of worm that biologists use for genetics experiments. And she would spend a lot of her time counting these worms to see how many of them had survived her experiments and how many were dead. And this just seemed like the kind of task that would be ripe for disruption with some of our modern image recognition technologies.
So how would you see helping her today in your current knowledge and capacity? What could you see a solution to help her?
I think there's a lot of these lab in the cloud kind of technologies that are coming up today where you have, well, there's not a lot of them, but I do know of some startups that are starting to think about this kind of thing where you have your experiments and then they're actually analyzed for you, or the analysis is automated for you, either by intelligent software or in the cloud by, I guess, well, I don't know what they do, but you could imagine like mechanical Turks or something like that helping you do some of this analysis, right?
As I mentioned before, like you can't go to any conference and not hear about Einstein. You can't go to any conference and hear about AI and ML. Is it just the sheer volume of data that's driving all this move to AI and ML, or is there some deeper trend in software that we should be aware of?
Yeah, it's the volume of data. It's also the advances in hardware that has made it possible to do a lot of these calculations that are needed for machine learning to do them a lot faster. And so it's a combination of those two things. I think it's the data as well as the hardware, and also the benefit that people are seeing from the competitive advantage that they get from applying these kinds of technologies and making their apps smarter.
So obviously, everyone should get out there and learn more about Salesforce's APIs and things that you have available. But what other toolkits out there and frameworks, packages do you recommend an architect or senior engineer who's really wants to get into the AI and ML space? What other packages should they be focused on?
Well, so I think engineers in general should start getting more fluent in the language of machine learning. And so I think we're fortunate to live in times where there's things like Coursera available to you where you can watch lectures by folks like Andrew Ng, even if you're not in university anymore. So I think definitely becoming more conversant in the terminology that is used is very useful. And then there's also a bunch of APIs and frameworks out there. I think taking up like a simple Kaggle data set and then working on it with something like Pandas or scikit-learn would be like good to just get started.
You mentioned a bit about a data pipeline. What are kind of the typical stages that you might need to go through if you're going to build an AI model and an appropriate pipeline for it?
There's a definite process for it. So you first start by prepping the data. You might join in different data sources, aggregate. You might throw out some of the data that looks like it's bad or outliers. And then you would do some amount of feature engineering. So this is things where you transform your data to generate new data that's likely more predictive. So you might take a numeric feature like age and then bucketize it into ages between the 0 and 15, 15 to 30, and then 30 to 70 or something, I don't know. So you manipulate your features to generate new features that are more predictive. You then train a bunch of different models on this data set, evaluate it, and then you go back into the cycle of data prep, feature engineering, model training, and evaluation until you find something you like, and then you deploy it.
Kathy O'Neill wrote a book called Weapons of Math Destruction, where she talked about bias in data sets. As you're building a pipeline like that, what types of things do you do to protect users of your system against ML algorithms that go awry?
There's a lot of research ongoing right now on how to construct fair algorithms, but I think one of the most basic steps that an organization could take to ensure biases don't get propagated from data to decisions would be to explicitly measure the kinds of biases you want to prevent. So for instance, biases in race or gender. I mean, the idea is if you can't measure something, you can't fix it, right? So I think just instrumenting your pipelines and just measuring the things you want to protect against is a big step.
How do you even identify things that can be surrogates for race or for gender or things like that?
I think people tend to exclude things like race and gender from their data sets, and they think that that's going to help them, right? But really, there's other things like zip code could be a surrogate for race, right? And so you need to be, it's not like just including race is going to save you from that. And that's what I meant by you actually want to perhaps explicitly include those factors so that you can at least measure the bias.
So you might want to include things that you wouldn't actually use in your model, just as a way of specifically measuring that something else isn't performing as a surrogate to that value.
Yeah.
Interesting. Okay. Another question I'm curious about when it comes to building data pipelines is sort of the difference between enterprise and non-enterprise ML use case or pipeline. What I mean is, how does building a data pipeline change or evolve when you're talking about a space that's more classically defined or more classically in the space of an enterprise developer?
The cycle that I described to you previously, where you're doing data prep and then feature engineering, model selection, and then evaluation. In the consumer space, you generally have one or more data scientists dedicated to building one beautiful hand-tuned model for a single data set that they understand really well. And in the enterprise space, this kind of goes out the window because you're building so many different models for so many different businesses and so many different use cases that you cannot have a data scientist dedicated for every single use case. And so you really have to think about what are the things you can automate. You don't need to have a human trying out all the different kinds of ways to engineer these features.
So given that, what is a data scientist in an enterprise versus a consumer-oriented company forced to optimize on?
So for consumer developers, you're optimizing for known use cases using data that you understand really well, right? But in the enterprise space, you're optimizing for many different, potentially even unknown use cases using data that you don't understand very well at all. And even if you're solving just one use case, you have to really build thousands of personalized per customer models because there's not going to be one model that fits it all.
Can you put that in context for me? Maybe give me an example of how this complexity evolves when you lack a deep understanding of the data itself?
I guess what I mean by understanding the data is, say I'm someone at Amazon and I'm trying to predict that someone's going to make a purchase, right, on the website. I'm intimately familiar with all the signals that can go into this prediction, right? And I know that I should, for instance, ignore signals like, was the credit card swiped? Because the credit card being swiped was more effect rather than cause, right? There's those kinds of things that when I'm intimately familiar with the data, I can say, hey, I don't want to include credit card swipes as one of the predictors. But when you're dealing with data where you have automated business processes, maybe filling out some of these fields, how do you tease apart cause from effect? That's one of the challenges that we have.
So when you say enterprise software and enterprise space, you're talking about when you're using like a COTS product, you don't have deep insight about the structure of the data? Is that what you're meaning?
Well, there's many different things I'm meaning here. So how this works at Amazon or Facebook or something is you'll have a team of data scientists working on this one data set, right? And they just have a lot of tribal knowledge about this data. Maybe there's some information about the data, and then they know, these are the things I should include, these are the things I should not include. And now there's a lot of manual effort there, which you cannot do in the enterprise space because every single data set is going to be different. So even if you look at a single object, like say the lead object, right, and you want to predict lead conversions, this lead object, in the case of a customer like Square, might have a whole bunch of custom fields about, type of business and blah, 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 which are different from all the custom fields that are there for a customer like Comcast. And so you cannot have a data scientist sitting there and say, hey, let's take this custom field and do this for this particular business, and then let's take this other custom field here and do this other thing for Comcast, because it just doesn't scale that way.
But that's the thing that I don't understand, is that the reason that you can do that is because you have insight into how the data is structured?
Yes.
So you're able to say this is a customer, so therefore a customer can make this kind of projections?
No, so with Optimus Prime, we're able to say that, hey, these are all the custom fields and these are their types. So now automatically do these things to these types. And automatically throw out these fields because they look suspicious, because they're too good to be true. They're more likely to be effect rather than cause and things like that. So we automate things that normally a data scientist would have to manually do for every data set that he works on.
So can you give me some examples of things that you can automate and kind of remove the undifferentiated heavy lifting of a data scientist?
Feature engineering is a great example, right? There's a definite bag of tricks that people try. And so if you have metadata about your features, there's a lot that you can do. So for instance, if you know that a field is an email address, you can automatically pivot out the domain of that email address, check to see if it's a very common domain, and that could be a feature. If you have a large piece of text, you can automatically extract the top 10 TF-IDF terms. If you have a phone number, you can automatically extract the country code, check to see if it's valid or not. There's many different things that you can automatically do. You don't need a human being to be doing that.
I see. So once you have the metadata that describes a particular field or set of fields, the relationship of fields, then you can do enrichment or cleansing activities, for example, to be able to verify those things are correct. I got you.
Like if you have a zip code, you can automatically join in census data and augment it with the average income, right? There's things like that where you don't need a human being.
But even with that insight, there's obviously still some huge challenges with building all these models for customers. What were some of the challenges the team faced despite having all this metadata and insight between the relationships of the data?
I think one of the challenges that people don't realize is that even at Salesforce, like even if we choose to focus on solving a single predictive use case, even that is extremely non-trivial. And that's because you have many different businesses. So you take a common use case that you might have, like customer churn. Every business wants to be able to predict customer churn, right? The tricky thing is that you could have many different data sources that are relevant to making those predictions. And you could have different business processes that are populating those data sources. And even if you have common data sources, they could have very different data shape. So you could have customer churn might be like, a really rare event for one business, but then like more frequent event for another business. And so you need to be automatically sampling your data in a different way. And so what that means is that even if you're solving just one thing, you're really building thousands of personalized per customer models for even just a single use case.
Yeah, I see. Okay. So earlier when we were talking about the enterprise versus consumer space, you mentioned an internal library that Salesforce uses to drive this layer, Optimus Prime. Can you take a second and talk about Optimus Prime? What is Optimus Prime?
So Optimus Prime is a machine learning framework that we've built for building modular, reusable, and strongly typed machine learning workflows with minimal hand tuning. So it's essentially our automated machine learning framework that we use to solve some of these problems that I talked about.
And it's a Scala library written on top of Spark ML, right?
Yeah, so it's written in Scala. It's currently built on top of Spark. Built it on top of Spark because it's great for working with large data. But we also built it on top of Spark ML in particular because we loved some of the Spark ML abstractions that they have for machine learning pipelines. But we are also looking to dissociate it from Spark for dealing with cases where there's small data and where, the overhead of distributed computing can be overkill, basically.
Yeah. Okay. So what makes this library special? I mean, what does the library give you that Spark ML on its own doesn't?
So one of the things is it's the features that you would build and the pipelines that you would build from them are strongly typed. And we do a lot of stuff with those types. So there's a rich hierarchy of types, and we use those types to do a lot of the automated feature engineering, feature selection, and model selection, and so forth. So those are some of the things that you get. Those are some of the machine learning automation capabilities that you get out of it. The type safety is also really nice for developer productivity. You don't leave a machine learning pipeline running overnight only for it to fail because you were trying to normalize a string column or something. I think the main thing is the automation, right?
Earlier, when you were talking about metadata on an email field, being able to do these different lookups, this is the language, the DSL that your developers use to build that automation?
Yeah, explain this without code, but you would just give your estimators a sequence of raw features and it would automatically, now based on the types of those raw features, go and do a bunch of transformations.
Yeah. And tell me something, is Optimus Prime open source? Can I go use it in my own tool?
It's not open source.
So what are some of the lessons that you learned that other people might be able to pick up on if they wanted to build a DSL on top of SparkML?
So one of the lessons learned is don't try to reinvent the wheel. The first version of Optimus Prime that we built was when Spark ML pipelines were still in their infancy. We essentially came up with an API that was entirely our own. But obviously Spark is like this huge open source community. It has an active community of developers and it's constantly getting better. So when you're building something like this, try to build it in a way where you can leverage developments in that community. And so that's how we built it the second time around. So that's one thing. Another thing would be always get feedback on design. Anytime we want to implement any new feature, we actually go through a design review to make sure the user interface is something that we all buy into and we think that it's a good change to the user interface. Because for a lot of these DSLs, right, if they're not usable, then they don't get adoption.
I don't understand that. When you say user interface, you're talking about the developer user interface of the DSL?
Yeah, the developer APIs.
Yeah, okay. Yeah. So what the actual, how it reads for a developer who's writing against that API.
Yeah.
Oh, very cool. I like that. So a design review for the actual API. That's cool. Okay, so in November, you're going to be hosting the Practices and Frontiers of AI at QCon SF. What are your plans for the track?
Yeah, for most folks, their initial exposure to machine learning is through Kaggle competitions where they might get this beautiful sanitized CSV data set, and then they try out a bunch of different models on it and then find a good one. But in real life, it's so much more challenging than that. You have to handle ETL, you have to handle schema evolution, you have to handle actually taking your model from development to production. And I wanted to hear from some of the companies in the world that have solved these problems in a platform way and built robust production-ready pipelines. And then I also wanted to see how new technologies in deep learning are being used in production today. So those were kind of the two themes for the track.
Very cool. Well, if you want to hear more about frontiers in AI, look for Shubha at QCon SF in November.